Let's welcome Neil Buesing. So he's a very good friend of Object Partners. So definitely happy to have him here. And yeah, we'll let him go through this and do his thing. Thanks.
Thanks.
I'll hop online.
Appreciate it. Yeah, appreciate being online to help. My Zoom abilities seem to be a little lacking tonight. We'll make do with it. So I'm Neil Buesing. I'm a principal solutions architect at Rill. As indicated by Donald, I used to work with Object Partners, was there for about 20 years. So know quite a bit of the industries here locally, and now I'm getting the opportunity to learn a lot of those elsewhere in the United States. And I appreciate Donald for inviting me to speak at the meetup tonight. And we're going to talk about building analytic pipelines. I want to showcase Kafka, ksqlDB, as well as Apache Druid. So a couple slides, get it out of the way. What does Rill do? Rill provides Druid as a service, more than that. But the idea is getting your data available at scale for doing your analytic processing. So we work with clients to get their data in through streaming it through Kafka, through batch loads and other platforms. And we build and help them build those pipelines as well, so then they have their analytical data that they can provide their clients. Like I said, we're pretty much built on Apache Druid. We provide a control plane that provides security, scalability, fully managed operations of that. And what comes with Apache Druid comes with Rill Data. So you can integrate Tableau to Druid, you can integrate Tableau to Rill Data. You can find out more online. What do? I'm a principal solutions architect. I help clients get their data into Druid. I help them get into Rill's version of that. And we use various tools. In addition to Apache Druid, we use Kafka, we use Kafka Streams, we use Apache Beam, and the list goes on. Primarily working with the clients to understand their data, model it, make it available in Druid so they can do their analytic processing. And Katniss likes to follow me around and works with me and provides me all the real guidance that I need. Takeaways from tonight, at least I hope so, is an understanding of Druid, an understanding of Kafka. I get the sense that where Kafka was 4 years ago is a lot different, so a lot of people are on that way in their journey, but we'll go over it. ksqlDB, primarily as the implementation of Kafka Streams for tonight. And we're going to look at developer tools that I built together to help my daily work. And then we're going to have some fun and build an OLAP pipeline. And I should probably make sure that I keep an eye on time so I get to those demos and I don't ramble like some people say I do. So let's start with Kafka. I'll ask at least those in the room, how many are new to Kafka? A little bit, okay. So I'm going to go through this pretty quickly, but obviously ask questions, slow me down if you need to, but we're going to go over a little bit because really around a lot of the stuff we're building now, Kafka's become the backbone, not only at the streaming aspects of Rill, but also within all the clients that I worked with in the last few years before joining Rill. Very high level, I like to show what Kafka is, because I think that its elegance is its design. The coordination of work is done by Zookeeper, and there's a lot of talk that that's going away. So I put that off to the side. As a developer, you shouldn't need to know about Zookeeper, not anymore. If you're operating, different story. Data engineering shouldn't have to worry about Zookeeper. Brokers, you typically don't need to worry about the brokers as a data engineer. You just have to know what's happening with the code that you're writing that's talking to Kafka. Every producer talks to every broker. Every consumer talks to every broker. You try to do tricks with load balancers and that and get in the way, you're just going to make the daily life of your development team, your engineering team have problems. So how Kafka scales is by pushing as much as they can to the clients. Therefore, the clients have to do all the work. The brokers replicate data to make it available and to make sure it's durable. So a Kafka broker is also a client and uses the client library. And And I've had some fun troubleshooting a few scenarios where the library got loaded wrong because I was doing something. And I learned, oh, it uses their own technology, makes a lot of sense. From a development standpoint, producer, you produce, and the producer decides where to send the data to. Typically, the client library gives you an algorithm that takes the key and assigns it for you, but you could decide to do it differently. And if you do, you need to make sure that's what your team's expecting, or you're going to create problems. Consumers read from each partition, and ordering is only guaranteed per partition. So if the producer's not honoring where keys are going to the same, then you're not going to get the ordering. How consumers scale is by partitions. So if you have two partitions, you can have two consumers. Druid takes advantage of this quite nicely in how it loads and shards the data is by partition. So if I have 4 partitions, I'm going to have 4 shards of data in Druid. They're all going to cover the same time. But if I'm not keying directly, I may get users in different partitions, which could slow down the queries and some other nuances. And then lastly, a new consumer comes along. They're independent of the other. As long as that data is there, it's going to read it. It's not a queue where you have to worry about stuff. So I like to comment on this just because I think it's pretty elegant. I've lived in Kafka for a while now. I like how it's designed, but it also impacts how you use it with your applications like Apache Druid and others that are taking advantage of it. Primarily for tonight, we're going to talk a little bit into the ecosystem, and there's a lot there. But you have your ins, which is usually your own producers or the connectors you use, which are configuration-based connectors provided for you. You have your outs the same way, and then you do your stateful processing in Kafka Streams or ksqlDB. You could use Spark, you could use Flink. You're not leveraging Kafka as the durability of those technologies, but that's what they tried to solve. And then lastly, you have your data modeling, your data governance. None of that ever makes it into the brokers. That's always at the peripheral. So that's in the clients, the producers, and consumers. So as data engineers, making sure we build good models, that's going to be on the tools that you're using that use Kafka, not necessarily core Kafka itself. And there's some variations to that. Confluent Enterprise does do some sanity checks of data if you enable it. But from the Apache Kafka standpoint, data governance is on you. And that's typically a good thing. Again, Kafka, high volume of data, durable, producers and consumers are independent of each other, and there's a rich ecosystem of it. I think a lot of people know what that is, but in case you're new to Kafka. So we're going to talk about ksqlDB. For the last 4 years, I have lived in the Kafka Streams world. So I developed Java applications for doing stateful processing. ksqlDB is Confluent's Kafka Stream app that provides a SQL-like syntax to do your enrichment, which from a data engineering side, from a presentation side, is great. I can show a lot in very little code. I can talk through what you're doing and so on. As far as a development team picking what technology to use, you will need to understand what limitations it may have based on providing you a SQL-like syntax. Are you a Java development team shop? Can you use Java Streams? Do you already do Spark? Do you already do Flink? That should come into decision. But from a data engineering standpoint, what we're going to talk about today is what do you do in that pipelining stream processing versus what may you do in Druid, and how do you decide where to do it? KSQL, like I said, is a Java application built on Kafka Streams. And you can deploy it over multiple instances, just like you can do your consumers, your producers, and your Streams app. It uses Kafka for communication and durability of the messages that are involved. And it provides a nice command line interface so you can write your SQL. Casey. Here is an example SQL query that I would use to bring data in from a Kafka topic into KSQL. So I have an OpenSky connector that reads from an HTTP endpoint and creates messages in JSON or Avro, but for the sake of demonstration, doing JSON. I'm defining what all those fields are, giving them strong type, and bringing it into ksqlDB so I can now use it and modify it in other streaming. For the most part, if I was using Avro, I wouldn't even have to define anything here because it would go to the schema registry to get, is it an integer or is it a string? The key is you need to know what data is coming in and I need to map it to a topic that KSQL then is managing for me so I can write SQL against it. Big things to point out, not only value format is where are you getting the timestamp? Is it from data within? Is it from the message itself? These are the key considerations. And when it comes to Apache Druid being an analytical database, time is everything. Here is an example of me building an aggregate in KSQL. So I am basically selecting the fields I want from that flight data, and I'm doing aggregations on it. Max is pretty straightforward. Latest by offset is if I get duplicates, I want to take the last one. And for something like aircraft data that's giving me updates to its positioning over time, that's an important operation to have. I then wrote 2 custom functions because I deployed KSQL myself that allows me to keep track of the distance traveled by an aircraft. This is where my aggregate's coming in handy. This is where I'm doing stream processing that required me to do it somewhere beyond Druid because I had to define what it means for my plane to be in flight versus starting a new flight. So I took a session window and said 30 minutes. If my plane is on the ground for more than 30 minutes, I'm keep treating it as a new flight. There are other ways I could have done it. I could use I could wrote an event and done it, but this worked really well into KSQL, allowed me to take my many updates of aircraft data and create an aggregate. So when Kafka Streams and ksqlDB did that, how did it do it? How does it share the work and allow me to create a pretty fast application to do this if I'm running at scale? Say I'm getting millions of positional data over time, how can I scale my application to do that? Well, with Kafka, you have your partitioning. So I'll create as many partitions as I need. If I'm keying by the ID of the aircraft, it's already on the partition that I want it to be on. So it's very easy for me to add a second KSQL instance. And because they're Kafka consumers, they each get a different partition. And because I keyed by ID coming in, I know that only aircrafts of 1 are going to the same instance. Aircrafts of 2 may be going to the same one or a different one, but all 2s will go to the same. And this is the heart of Kafka Streams, is using that key value to get your data where you want it to be so you can do your aggregate. So what else does Kafka KSQL need? It needs availability of that data. If I was reading the Kafka topic to get the aircraft where it was 10 seconds ago, I have no way of doing that in real time. Kafka is just a log that you add events to. So I needed a place to make that available. Kafka Streams puts that into a ROCS database. It's a key value store. It's a little bit more than that because it can also do range scans. So when it's doing windowing, it has some advanced key value store. And it will also create multiple instances based on the windowing that you have. So next day, it can throw away the previous day. A lot of that gets handled for you, but if you have to tune them, they're there to tune. What if my KSQL server goes down, my RocksDB database goes down with it? It needs to be durable. And that's where Kafka comes in with Kafka Streams, KSQL. It puts that durability into a topic. If you're using Spark, Flink, the durability is on those clusters that you've built to do that stateful management. So now if I come to the scenario, what if my input data wasn't keying by ID? Say it was keying by aircraft location, and I want to calculate distance traveled on an aircraft. Right now, I'm out of luck. Aircraft 0 could be going to the top one or the bottom one, depending on which location it's in. So what Kafka Streams does for additional scalability is it uses repartition topics. So if my input data is not well defined or I'm doing more advanced stream processing, I will rekey my topic to the ID of the aircraft and add another state to my SQL processing. So now I can ensure that all aircraft of ID 1 are being worked on by the same instance. And that's how KSQL gets me that availability and scalability to do work at large volumes. Now, if one of these KSQLs crashed and I didn't get another one up in time, all that work would then move back to 1, and it would use the changelog topic to rehydrate its state and then reprocess all those aircraft coming in again. Typically, in production grade environments, you're going to set up what's called standby workers to potentially have all that state being read into the other instances just in case something else goes down. So if your SLAs are 99.999, you may need standbys. If your SLAs are 99 and your state stores are relatively small, maybe you just have pretty aggressive cron jobs to go in, kill -9 and restart. That's on you or your operations team to help build out Kafka Streams or KSQL to do that. I mentioned windowing, and I think windowing is key to where Kafka Streams and KSQL shine. So I want to take the time to talk about how you would window your data. There's 4 avenues in Kafka Streams for windowing. 3 are available in ksqlDB. The key is 2 are epoch based. So wall clock time, midnight UTC time, and 2 are record based. So when you're wanting to enact like aircraft, 30 minutes of inactivity, that is record based windowing. And you have both of those available. The key is here is really in this, I think these 4 slides should summarize it well. Tumbling windows is epoch based, 1 window per event. It either goes in 12 to 12:30 or 12:30 to 1. Bad for fraud detection. If someone's using your credit card at 12:29 and then 12:31, they may get away with it if your fraud's saying too much activity. So not a good choice for that. Hopping says, you know what, I still want epoch-based windowing, but I want duplicates. So I'm going to have staggering windows every 5 minutes, every 10 minutes, every 15 in this case. And I'm putting my event into 2 windows in this case. Fraud detection, I may get 2 events, but I'm not going to get 0. Depending on where it happens, I may get 2, and I will have downstream deduping fraud alerts so my phone isn't going berserk, but I'm not missing something from that. These are both epoch-based, and this is where, when you're using something like streaming, you can get away with using Druid for doing some of the additional collection of the data, because Druid is also epoch-based, being a time series database. Where KSQL comes in and Stream come in, beyond that is really what's around record database, time windowing, and that's where the other 2 come in. Sliding is not available in ksqlDB. It was introduced, I think January is when 2.7 came out. The idea is I create multiple windows, but my windows are per the event time. And if I'm getting a lot of updates, I may create a lot of windows. Sanat and I, in a previous life for me, implemented this. I had Sanat implement this, and I thought this is great. We're going to get to record-based eventing for the aggregates we need to build. And our RocksDB database became non-performant because our aggregates were so many updates that we were getting for only a few, but we were getting like 1,000 windows per event. And if you do that over 1 million, 2 million records, Rocks was just not keeping up. I did not understand how sliding worked. I thought it would remove records as it goes, and I was wrong. So lesson learned, try something out, push it, and see if you really understand it. I like to point it out because of that learning, because I was looking forward to it and then realized it doesn't quite meet the use case. You don't force your desired windowing into your need of windowing. Lastly, this is the windowing that I tend to look more like very much to where old web site technology. A user is staying on, as long as I come back to my travel website every 15 minutes, I'll never log out. So you only log me out after inactivity. The same is true for session windows. So this worked well for my aircraft, is as long as the aircraft is on the ground, I'm not going to record an event. And if I don't record an event for 30 minutes, I'm going to start a new window. So the red stopped for 30 minutes and the window started over at 12:46. Green always was in 30 minutes, so that session grew. It could grew on for years if you let it. And the same for the yellow. Different kind of problems you can get into with long duration windows. You may have to tune how long windows are kept. To be honest, everything's a little bit different between how Kafka Streams store the windowing. So it's like, you always want to see what's going on, what windowing it's creating. The key with session is Kafka is immutable. So that change log for time-based windows, it's epoch based. So I always know the time that I'm in. I don't have to change the key. I could grab that aggregate and then recreate a new key of exactly the same. And Kafka's change logs are what's called compacted, last one wins. And I can eventually get rid of the first one. Session windows, I have to keep track of the start and stop. So I have to change that key every time. So you have to tombstone the original and create a new one. So it does create a lot of chatter in your change log. You may wonder what's going on, and it may actually degrade performance in certain cases. So I bring this up primarily because I want to talk about when I do things analytic in Druid and when I do it in streaming, but it's also useful if you're going to use streaming technology with windowing. My reaction is, from my lessons learned, you have to learn it. You can't just treat it like a magic box, because when you do, you're going to fail like I did. Summary of KSQL. It is a database. It's a very specific database. It's primarily built on streams. It's built with Kafka Streams, but not all the features are there. And the SQL syntax has a flavor of SQL, but it has things that aren't available in traditional databases like windowing. It follows Apache Calcite's parser that introduced these windowing hopping session windows. So it's very familiar to those in other things like Flink uses. I think Flink uses Calcite. I'm not 100% sure. But Druid uses Calcite, but doesn't use windowing. But that parser and that language add-ons for providing streaming should be comfortable to people even outside of KSQL. It wasn't to me because that's the first time I used it. But if you're using other technologies that are using Calcite, you're going to see that language is going to be familiar to you. So let's get into Druid. So Apache Druid is an analytic database with time series data. There's a lot to it because it needs to be performant or no one's going to use it. These are the components of Druid, and you scale middle managers and historicals for the load you need for both query time and ingestion time. There's a lot of other things out there that gets used. Most part, you just have to worry about the middle manager and historical if you want to understand what it's doing. For querying, you're mostly just going through the broker, the router or the broker, depending on how that URL gets in. I'm not quite sure if you always go through the broker or not. This is typically what's happened. So that time series data gets put into a file that's similar to Parquet, column-based files. It's the Druid format, but it's column-oriented like Parquet. And it gets thrown into deep storage. Deep storage S3 buckets, Google buckets, whatever your flavor of storage is. Once an hour of data is read in, it's going to be put into deep storage and it's immutable. It only needs to be brought out if it's being queried. And you bring up a lot of historicals to make sure you can query that data. And middle managers are how you get your data in. So for batch, you're just reading from S3 or files, bringing the data in, putting in Druid, putting in deep storage, letting historical read it. For real time, so Kafka in, not only is middle manager getting that in, formatting it in Druid, storing it, it also has to be made available to the query engine. I got comfortable with Druid by by walking through how it does things. I'm presenting and how I learned it. There's a lot of other instructions on it. Let's see how it goes. So I like to look at the file format. The file format, again, everything's based on time. So the first thing is you determine how you're going to store your data. Is it hour chunks? Is it 15-minute chunks? Is it day chunks? All depends on how much data you have coming in. If you're doing batch, you can probably get a better sense of where this is by looking at your input size. If you're loading from streams, you may have to play around with it to know, am I doing it too small? More segments, the more queries have to go and find the files to read. Then there's query granularity. You can leave the timestamp alone, but typically if you're using Druid, you're trying to reduce the amount of data you're storing. So I may say, I'm only caring about 1 second timestamp, 1 minute, 1 hour. So I'm going to remove that noise, for lack of a better word at the moment, and just wipe that out and store per minute in this case. So what's happening is I have all these records going in. The dark blue is the time, the blue is my dimensions, and the cyan, if I say that right, is going to be my metrics. But for here, for query rollup, I have all these seconds. I'm telling Druid, get rid of that. So it's going to store that with that wiped out. That's it. That's query rollup, and there's predefined queries sets that you can do. What this gives me, secondly, is I have my time now rolled up. Now I have all these column data, my files like Parquet, if you're familiar with Parquet. I am going to index those files. So rewards, there's just 3 of them. I want to put them in a map, and then in my file store 0, 1, and 2. For area code, there's a few more of them. I'm going to do that. But now my row data is getting pretty small. Druid doesn't have to store a lot of data if my cardinality isn't high. So now if we go through that, I did my dimensions and my time. Now where it shines and what Druid can take advantage of that is in aggregations. And with aggregations, you can do roll-ups ahead of time. And or basically do some pre-aggregations while my data is being ingested. And how well this works depends on how much cardinality is in the data that I'm collecting. So here's an example. A record comes in. The first thing I'm going to do is I'm going to roll up my time, and I'm also deciding that for phone, I only need the area code. So I'm transforming that data. In Kafka Streams Connect world, simple message transform. Anything that I need to do is right there in the message. I'm also going to copy the quantity over to max, and I have one row. Next record comes in. I'm again going to cleanse the data. In this case, the reward's different. So I'm not going to roll up any data. Now another record comes in. I cleanse that data. Now look, it's 102, it's gold, and it's phone. I can roll these up. For quantity, my quantity becomes 11. My max is the max of the 2, and now I have 2 of them. So I rolled 2 of them up into my count column within Druid. Another record comes in. This is silver. I can roll that up into silver, and my metrics of sum and max and count all can be pre-computed at storage time. This one comes in. It's again able to be rolled up. Another one comes in. This one has a different area code. It cannot be rolled up. One comes after it that's the same as above. It doesn't matter. It can jump the line. Rollups don't care because all the times are now identical, and it can be rolled up into that top one. I keep going with this. Bronze is new. Silver 651 is now a different time. It can't be rolled up. This new silver came in. It can be rolled up. So on ingestion, in this case, half of my data was collapsed into other rows that already existed because my dimensions had a low cardinality. And this is where Druid can shine. And this is where I talk about, you know, those epic windowing that I was talking about in KSQL. Well, I have epic windowing here by 1 minute granularity to do my quantity, my max, and my count. So I can let, in some cases, Druid do some of that stateful processing because my metrics align with what Druid needs. Lastly, I want to talk one last piece on Druid here. people go in and go, oh, this is all great. How many unique users placed an order? And you go, that's going to typically destroy my cardinality. Now, because users are going to have typically I'm not ordering two things from the same retail company within the same minute to where that roll-up's going to happen. So pretty much my roll-up's going to go away if I store user IDs in the system. So what Druid does, it uses DataSketches, which is another Apache project that does Bloom filters and other things to approximate uniqueness. So I can then keep track of unique without it affecting my cardinality. So here's a slight more exaggeration of how it works, because I don't really, if I ever look at the data in Sketch, it's Greek to me, it's just a bunch of bytes. But Neo, this is where that name replace came in. This was Neil, and I did a global change, thinking my name wasn't anywhere else in the presentation. Neil comes in, and he's a unique user. So I'm going to create a sketch. In my simplified world, that's just the first letter. And I have a count of 1. Trinity comes in, rolls up. I now have Neil and Trinity in the sketches. Again, in my simplified world here, I'm doing first letter sketching. So I have a really poor sketching algorithm, because if Neo and Neil were actually in my database, they would not be considered unique. Trinity comes in with a different reward, that would be separate. Neo comes in with gold again, it adds to the count, doesn't change the sketch. Again, that filtering, this is black box magic to me still on how those work. Trinity comes in again, doesn't change that one. Morpheus comes in at the end, it gets rolled up, it adds to the count, and it updates the sketch. If you look at how Druid then stores this data, I did not cause any more rows to be kept than if that sketch wasn't there. My issue is how much space I give to that sketch determines how well that sketch approximates. So again, it's an approximation. For a lot of analytics that people are doing, approximation's okay. So when it comes to rollups, other things to point out, there is perfect rollups and best effort. For streaming, it's only best effort. If I have multiple partitions, Kafka's or Druid's not sharing those partitions. So data that's in separate partitions are not going to get rolled up. That's going to have to happen at query time. Now, Druid does have compaction that allows rollups to be, or segments to be compacted, but that may not happen right away or will not happen right away. So you have to realize you have to query your data as though you're doing that group by aggregate. Because if you don't, you may get duplicates because that aggregate wasn't necessarily done to completion on ingestion time. Granularities, again, are epoch-based, UTC-based. So for those that are India that have half-an-hour time zone differences, you're not going to be able to use hour-based granularities if you need something in those time zones. You're going to have to use 30-minute, or you're going to have to deploy Druid with a time zone that's not UTC. It's going to use the JVM's time zone, which typically, at least I think so, I don't think there's a separate setting, is the time zone that's being used. Those are the predefined granularities. Again, all epoch-based. Other limitations is you will see aggregates in Druid for first and last. When it rolls up and keeps the first, it doesn't keep the timestamp of the first. So if I have multiple segments, first may be, there may be 2 firsts out there, and when I group them together at the end, it may not be the real first that comes back. Because I had 2 Kafka topics, 2 segments, they got separate, they both rolled up separate firsts. I now do the aggregate. I don't know which first is going to come back. Druid's not going to tell you not to do, you can't do it. You're going to do it, and then you're going to learn you did it wrong. Because I did it wrong. And that's because string actually has built in storing the timestamp within the aggregate. So for strings on query time, as long as I'm doing a first aggregate method at the query time, it knows the timestamp of each string that it kept and know which one was first and which one was last. So you could cast data to string on ingestion and use first and use last. So back when I was showing first and last offset of ksql, I couldn't do that in Druid if those were numeric, but I actually could do something similar to that if they were strings. And then lastly, it's up to you to write your query in Druid to do your aggregations. So if I'm counting counts and I'm summing counts, you're going to get two values. You know how that count number went up every time I rolled it up? If I count that row, I'm still going to get one back. If I sum that count, I'll get what was stored in there. So the trick in Druid is I want to know how much my data actually rolled up. I can run this select statement and I can see how good a roll up did my Druid query do. Other things, again, Druid's for analytic processing. If you're wanting inventory, real-time user transactions, Druid's not the place to do it. If you have data that's not time series, it's also not the place to do it. I don't know of analytics. I can't think of an analytic use case that isn't time-based. I'm sure there are. You have a lot of pre-aggregation possibilities. There are limitations. You can't do averages. You can't do first of integers. There's opportunities for those to change over time, but there's extensions and there's features that people have added. But in the core Apache Druid, that is what's available to you. So we're going to do a demonstration. Looks like I kept enough time to do both. At least I hope to, provided my Docker image works. We're going to do two OLAP streaming apps. We're going to talk about the data. We're going to see what's being done to enrich it. Maybe help figure out why I chose something along the way over the other. First one is the point of sale. So you saw that in my rollups. I'm tracking user purchases and store purchases, not only number of orders, overall quantity, max quantity. I'm going to bring that in through a connector that's available for Kafka Connect. It's open source, that I generate dummy data. And I'm going to pull in user and store data from files. I'm going to use ksql to enrich that data. So I have user ID 1 in that input. It's going to look up user ID 1 in that table, say they're a gold member, and their area code 612. And then I'm going to push it to Druid. The other one is I'm going to do that OpenSky, the one that I showed there, where I'm reading in data, I'm enriching it based on event time, and I'm going to push that to Druid as well. So I'm going to do a demo. If I can get there. So I want to spend a little bit of time on this. All my demos are done locally. I run Docker, and I spin up Kafka, Connect, ksql, Druid. I have other things on there. This is all open source, freely available. A link will be provided at the end. Where I try to do my work, I am fortunate to have 64 gig, so you may have to tone it down if you're on a less fortunate machine. So I have all these services running, my Kafka's running and that. So I am going to create all the pieces, and I'm going to do that quickly here through scripts, and we'll talk through it. But I'm going to create the topic. Whoops, I'm running up again. Wrong script, but it's already up. So I'm going to create the topics, and it's important to do that because you want the partitioning correct. You don't want auto creation. It's been through a lot of those connectors. So the connectors are configuration driven. So the data gen, and I'm going to show them a little bit. Then the two SQL statements or ksqls are written to enrich the data, and I'll show them here in a bit, but I want to get the data running. And then I spit it out to a topic. So I have shortcuts. So if you see KT, it's Kafka topics. I have all these tables that are being created by K-streams to repartition the data, to make it durable. That's all shown here. The orders enriched, the data, how it's coming out is here, and it's orders. So I can do a quick look at orders. This is the dummy data that's coming in. User ID, store ID, dummy zip code and address that I'm not using it. And here is orders enriched. So after KSQL has modified it. It's attached the user reward. It attached the user's area code, the store ID, and so on. Before I go in and show that, I want to get Druid up and running, so it has a little bit of time to do its work. For Druid, I am actually taking that one topic and loading it into 4 tables because I want to show you the differences between them. So while that's now running, if I go look at the connector, I'm going to look at that order connector. The order connector is the data gen connector. So you go out to hub at confluent.io or go to GitLab, GitHub, whichever one is your one you like to search at, and look for some. Data gen is one of those. You can find it either way. You learn how to configure it. There's a standard JSON syntax to configure it. I give it an Avro order file that's modified slightly by this generator to say, give me orders, generate random user IDs, random stores that are confined to 1 to 1,000, order numbers ever increasing, random quantity of 0 to 10. So basically dumbing out a point of sale order. It doesn't generate a timestamp, so I am grabbing the event time and making it my order timestamp. There's a lot here. I think it's useful for data engineering to go to a place to be able to generate dummy data quickly, because if you're a consultant at a client, you sometimes don't have the luxury of using the data of your client to talk about the tools that you want to talk about. So coming up with large amounts of data to demonstrate something has been a bigger challenge almost than the demonstration itself. So this data gen tool come in quite handy for that purpose. If I was at a major retailer in town, I doubt they would let me use their order data to demonstrate this to you tonight, but maybe a few years ago I could have asked them. If I look at the KSQL that I ran, I have orders. Orders is just bringing that data in, as I showed earlier, and giving it data types. Order enrichment is where I joined to my K table, so a compacted topic of users that was stored in rocks that I could look up by key, and joined by stores so I can enrich it. Now, the part that's interesting here, I didn't plan on talking about it, but I do that. Notice these join repartitions, left join and join. That's because my orders are coming in keyed by order, but I need to join to users and I need to join to stores. I put those in traditional topics that are sharded by the number of partitions. So in order to find my store, I have to rekey my order where store is the key so I can find the store to join it together. And the more complicated joins you have, the larger number of partitions you're going to need. The lifespan of these repartitions is usually pretty small, but they add up. And you're going to see a lot of this going on. KSQL does a lot of this for you. Kafka Streams does a lot of it for you. But it's important to understand it because when something goes wrong, you're going to need to go, why is my data not joining? At a coworker from a few years ago, a repartition topic in a Streams app had the timestamp of the original message. And then it got put into a compacted topic. And the compacted topic immediately compacted because the timestamp was of the original. So there was some weird behaviors of Kafka trying to be smart and doing no, actually it wasn't a compacted. It was, I have a repartition of like 30 minutes and my message is 2 days old. It's potentially could be immediately discarded because of that. I'm not spading it well, but the point I'm trying to say is you want to understand how this works because you're going to be asked to go in and what went wrong, even though you're a developer, because operations of someone operating KSQL shouldn't have to understand how your data is being transferred through it. They have to make sure KSQL is operational, not the timestamps, the repartitioning, the partitioning. That's on the developer. That would potentially be on the data engineer building up these queries. There's a lot there that isn't part of traditional. So I've talked well long enough to go back in and look at the data. So I'm going to look at one of the stores. So order with store zip code. I'm going to query it. And I have, I was querying saying, give me only the first 3 digits of the zip code and how many counts I have and how many quantities I have of that order. It doesn't make a lot of sense without knowing the actual data. So let's just show how that actually looks there. So in the store, I have that count. Again, that count was rolled up. I have quantity was rolled up. The zip code. Notice how there's only one zip code being stored for 140, 142. If I was grouping these and not splitting by time, I would still need to roll those up together. And because I'm shrinking the store zip, my counts is greater than what's seen here. So if I go back to it, it's again grouping the pre-aggregates as partial. I then truncated my zip codes so I could group more. I could never group less. So in other words, I grouped up I got my max based on zip code. I could find the max of 55414, not just 551, but I can't find the max of two different, which table is this? Two different stores, because if two stores were in the same zip code, they got rolled up together because I'm not storing the store ID. What I find most interesting, so what I did, let me go to this table. So I have order store, which contains the store zip code, and that's it. So you would expect 1,000 stores with 1,000 zip codes. I lowered it, it's not 1,000 zip codes. That would have a pretty high roll up. There's not a lot of stores. Users, I have 1,000 users, but I only have 4 rewards. None, gold, silver, bronze. Sketch, same thing, but I added in the unique user count. User reward and store zip, I'm now storing store information and user information into the same table. So with that in mind, we're going to run this query that gives me the current count. So I counted every row in all 4 of those tables. Because data's flowing in, they're not exact. If I shut down, they would be the exact count. And the count's about the same because I did everything. I said group by 1, which is a hard-coded string. So I'm getting the count of all the rows and the sum of the counts, and then the sum of the quantity. So these 102,000 counts of users, I'm able to store in 36 rows in the database because I have gold, silver, bronze, and none, and I've been running for a few minutes and I'm only grouping up by minute. So if I went in and limited by 1 minute, I should have 4 or 8, depending on, I might have 2 partitions running. Can't remember. Notice the sketch where I get in the user uniqueness didn't add to any of the rows. Each row is wider, but the actual data within the row is not. So if I go look at the data source, I could go in and look at this. Well, because it's running, it doesn't show that. So I should have checked that. User reward and store zip code, that has the most rows. My cardinality is increased. So as you use Druid, and this is a common question with a client's going to come to us and say, I want to add this new dimension. How much is it going to cost me? Well, you have the data coming in. You have the query time to do it. But most importantly, you have, well, third, you have the storage of the field itself. But most importantly, if that client is relying heavily on rollups and that cardinality on that unique metric is high or very atypical with the rest of the data, you may start exploding the number of rows you have in your database, which would slow down queries potentially and definitely increase storage. So that's the demonstration of there when people say, I want to use Druid. Why do I want to use Druid? A lot don't use, I shouldn't say a lot. There are many people that don't use rollups. So it's not like I point out as rollups as the only reason you use it, Druid. But it is a major feature that if you don't understand it, you build something leveraging it. And now someone, a new data engineer, a new manager comes along and says, I need to track this field. It may increase cost. You may want to create 2 data sources and have users separate from stores because you never do analytics on those together. It's up to you. So while that one's there, I'm going to try to shut this one down and start up the other one. So in all the scripts, I run, I have scripts in each demo project. It shuts down all the containers, Docker down -v, so all the volumes get wiped. You should be able to spin one up, walk away, shut it down, and your machine should not have any more memory than the images it needed to download. Knock on wood. At least that's my goal. This last one's going to take a little bit of time to start up, so I'm probably going to go back to slides, let it come up and run, and then we'll talk through it because I want to try to get to make sure there's time for questions. So I'm going to go to OpenSky, and I'm going to do an up on that. So up is bringing up a different Kafka Connect, one that talks to OpenSky data and enriches that through KSQL using the distance and that I created. It's then going to push it to Druid just like before, but I only have one thing going to Druid. And then I'm also setting up Superset to display that data in a graphical way. Superset is an open source visualization tool that can talk to a variety of databases, including Druid, and has some nice visualization tools on top of it. So I have the script. Nothing's fully running yet. Once it is, I need to do the startup. So to try to get through, I'm going to come back to that. So we'll talk about some of the things learning here. When do I use Kafka Streams, KSQL? When do I use Druid? A lot of event time versus epic time is a big deciding factor. Those positional aggregates, not a big deciding, but I did all that first and last within KSQL because I knew I couldn't do it in Druid. And then I learned I could do it for strings. So something I learned, I wanted to share it. Accumulative metrics, like simple single message transformations like sum, max, min, counts can be done in Druid if you can roll up your data. If you need something more than that, you're going to need a streaming platform to do it, like KSQL, Kafka Streams, again, Spark Flink. Transformations, you can do it in both. So if I have a phone number, I need to shorten it. Druid provides you that on ingestion. Obviously, you can do that in Kafka Streams because it's Java code, and KSQL provides substrings functionality. Things to watch out for. Apparently, I had more metrics to comment on, and I left it open-ended. If you have duplicates, Druid's not going to dedupe things. Druid's going to roll them up. So if you're getting duplicates, you may get double counting, triple counting. So you need to understand what your aggregate's doing. OpenSky has this problem if I query it wrong, because I'm creating point-in-time information of aircraft, not grouping data. So if I'm actually summing up my data for that, I'm going to get double counts. I'm counting that aircraft every minute if I'm looking at data for a bigger period of time than I'm reporting on. And then metrics that aren't there, that. I want to thank Sanat for being a big tester of my local environment through the last year that I've known him. He will ask questions, he will use it, we use it at a client together. He continues to use it, play around with it, help me identify countless bugs with my Druid setup. Countless things, can't think of a nicer person to have gotten to work with, and I appreciate all that he gets to do for me. Again, for Donald bringing me on to talk, it's been a pleasure getting to know you and get involved with the data engineering aspects here. I'm going to go back to that demo. Hopefully it's loaded up. If you're interested in my ecosystem that I use daily for building demos, for building pipelines, it's located here. It's called Kafka Local because that's how it started. I've added stuff to it. MySQL 5, MySQL's on there. So let's see if I can go back to the OpenSky and do setup. And if setup works, this again is creating all those connectors. We can go in and see a nice map of aircrafts over a given region of the United States, if I succeeded. So now and I knew that would not work because I've always had issues with this one. So I need to go into my Superset script. And it still didn't like it, which is typical. So that's the problem. Let's see, did the wrong one. Superset has an API. They create a token, and I can do everything. Nope, manually. And this is the one I should have had up first. So create the database. I assume that worked. Did not create the data set. So let's see here. There we go. So we're going to go and, well, let me first look. So I have two topics. I have flight data coming in. I have flight summary coming out. Flight summary coming out is a bunch of aggregated data where I've found the nearest city for an aircraft, and I use it to find the nearest state. I am then going to go to a Superset dashboard. I am going to go to a chart that I, again, built once through the UI and pray I never have to do it again because it's pretty tedious. I'll show you that in a bit. So I know there's 43 aircrafts over Minnesota right now from OpenSky Data because I threw that data in. I did a nearest city lookup in KSQL. I took the nearest city, found the state that that nearest city is in, and created an aggregate, brought it into Druid, and I didn't do any roll-ups because I wanted to make sure I only got that 1 minute worth of data. So if I do this quick, I build a dashboard. I've never been able to build a new dashboard through the scripts. So I go in and find a chart, bring that over here, save it. I go in and do the view query, maybe. This is the query that Superset created. Well, I created through those scripts to round the data to get it to that minute interval that I'm streaming in through KSQL to make sure because every time I get a new aircraft position, I'm creating a new event. So if I did any type of group by beyond nearest region and I was emitting events more than once per minute, I was going to double count everything. So this is the example where I go, you build all these streaming things up, you're doing all this in KSQL. Streaming platforms like to emit as they go. So if I all of a sudden increase emission every 5 seconds and I'm doing 1 minute windowing in Superset, I'm now counting my aircrafts 10 times, 50 times, 100 times. But if you build it right, and for demonstrations, I don't have to run this in production, I'm able to use openly available data, openly available aircraft position data with city data and find out how many aircraft in their system are over California right now, which is 280. So that's my platform. I'm 1 minute to where I wanted to be. So I'm going to call it good and open up for questions. Stop.